In this video, we are going to define dynamic storage automation policies with Crystal. In the storage monitoring system, we can see a tenant executing a write-oriented and oscillating workload against the system. We can see that the workload has high load periods and low load periods. Our objective in this demo is to enforce a dynamic storage policy with Crystal that enforces data compression for tenant test only during low load periods. As we can see in the workload metrics tab, dynamic storage policies can be activated based on one or multiple workload metrics. In this case, we are going to use the number of put operations per second for a single tenant. As we can see, the distinguishing feature of a dynamic storage policy is the when clause. In this part of the policy, we define the conditions that will trigger the execution of the policy. In this particular case, we say that the number of puts for this particular tenant is fewer than 3. Once this policy is instantiated, now we can observe its behavior and its effects on the workload. Internally, dynamic storage policies are implemented as distributed processes that are subscribed to certain workload metrics. In our example, a new distributed process has been deployed transparently and is subscribed to the number of put operations per second of tenant test. At this particular moment, the number of put operations is higher or equal to 3. So this means that the process is evaluating the trigger conditions to false, and therefore compression is not working. Now, the workload is becoming less intense, which will trigger the activation of the dynamic storage policy. In particular, this can be observed in the SDS policies page. As we can see, now we find a new static policy of compression related to tenant test, and this is because the workload has satisfied the trigger condition of the dynamic storage policy. The effects of compressions can be visible also in the transfer performance of object requests. As we can see, as the workload becomes more intense, again, the dynamic storage policy deactivates compression, as we only need compression during low load periods. this picture, we show the effects of compression on the transfer performance of PUT requests for several periods that the dynamic storage policy trigger compression. For more information, please visit crystalsds.org and join our GitHub community. Thanks for watching.